Welcome. Today we're going to be doing Chapter 6, Section 5, and we're going to be talking about trapezoids. So first of all, let's talk about the definition of a trapezoid. So a trapezoid is a quadrilateral with exactly one set of parallel sides. So we call these one set of parallel sides the bases, and you can see that the bases right here are red, and I'm just highlighting them in red so you can see them again. Those are our bases. They have exactly one, so no more than one, no less than one. One set of parallel sides. We call those our two bases. Our other sides that aren't parallel, we call them our legs. So in this diagram, that would be AD and BC. Those aren't parallel. The other thing about trapezoid is our base angles. So we call our base angles the pairs of angles that share the same base. So for example, this angle D right here and angle C, those are base angles. Those are a pair of base angles. Same with, let's see, angle A and angle B. They're also base angles because they are on either side of the base AB. Those are our two pairs of base angles. Okay. An isosceles trapezoid. So an isosceles trapezoid is a trapezoid that has non-parallel sides that are congruent. So the two pairs of sides that aren't congruent in an isosceles trapezoid, the two pairs of sides that aren't parallel in an isosceles trapezoid are congruent. So I like to kind of connect this definition back to what I know about an isosceles trapezoid, or about an isosceles triangle. And an isosceles triangle, if you remember, that's a triangle. It has a base and two sides that are congruent. Same with an isosceles trapezoid. We have here, we can call, and then the triangle, that's kind of like the base of our triangle, and those two other sides are congruent. We have except for in a trapezoid, we have two bases, but the two sides, or our legs, on either side of the bases are congruent. So I kind of like to connect those two words together with isosceles, trapezoid and triangle. They both have two congruent sides. Okay, now is a great time to pause this video and grab your theorem packet if it's not out already. So theorem 6.12, if a trapezoid is an isosceles, then each pair of base angles are congruent. So if we take a look, that means in this isosceles trapezoid, ABCD, that means angle A and B are congruent, because right there are a pair of base angles. And angle D and C are congruent. That's our other pair of base angles. Theorem 6.13 says that if a trapezoid has a pair of congruent base angles, then it is isosceles. So for example, in this trapezoid right here, ABCD, it's labeled that angle D and angle C are congruent. And we know it's an isosceles trapezoid. It's telling us that right here. Because one pair of base angles are congruent, then it is an isosceles trapezoid. Okay, let's do some practice problems. So PQRS is an isosceles trapezoid, meaning the two legs, not the bases, are congruent. Find the missing angle measures. Well, let's see. From theorem 6.13 that from theorem 6.12 that base angles are congruent. So let's see. I have one pair of base angles right here that is S and R. They're congruent. They're either on either side of that base SR. So since S is 50 degrees, R also has to be 50 degrees. They're congruent. Now I have a second pair of base angles right here, P and Q. I know that they are both congruent as well. Pairs of base angles are congruent. I'm going to say that P and Q both have X degrees, okay? They're both congruent. Well, I know from earlier in this unit that quadrilaterals have an angle sum of 360 degrees. So I know that 50 plus 50 plus x, whoops, plus x degrees plus x degrees has to equal 360 degrees. Those are my four angles, 50, 50, x, and x. Their sum has to be 360. Now if I take a moment and combine like terms, 50 plus 50 is 100 degrees, plus, well, I have two x's, that's 2 times x degrees, that has to be 360. Now I just get to solve for x if I subtract 100 on both sides. I'm left with 2 times x degrees equals 260. Divide by 2 on both sides. I'm left with x degrees equals 130. So that means right here, angle P is 130 degrees, and so is angle Q. Okay, we have another definition. The mid-segment of a trapezoid. A line segment that connects the midpoints of two non-parallel sides of the trapezoid and is parallel to the two bases. So let's break that down a little bit. So in this parallelogram, or in this trapezoid, we have our one base B, C. Let's see our other base. I'm not sure if I, nope. Right there, A, D, and they're parallel. Then if we look at our two legs and we find our midpoints of our two legs, so let's see, the midpoint of leg BA is going to be M right there, and that divides it into two equal halves. BM is congruent to MA, and if we look at our other midpoint on the other leg CD, if we find that midpoint, that's N, that splits into two equal halves. CN is congruent to ND. Then if we connect those two midpoints, we get the mid-segment. Mid-segment, if we just kind of break down that word mid, in the middle, in between segment, that's like a line. So I kind of think of it as a line in between. And it's a line in between both of the bases, right? And it actually ends up being parallel to both of these bases as well. Okay, I have a formula for you. The length of the mid-segment of the trapezoid is half the sum of the length of the bases. So that mid-segment MN is 1/2 times, let's see, our base BC plus our base AD. I also like to think of this as the average of the two bases. If you remember the formulas for finding average or mean, it's the same as finding the average of the two bases. Okay, let's practice this formula. Let's see. Find the length of the midsegment MN in the trapezoid. So let's see. I know that one base is 8, the other base is 14. That means we're going to do, to find the length of the midsegment, we're going to do 1/2 times 8 plus 14. Well, that would be 1/2 times, well, 8 plus 14, that's 22. 1/2 times 22 is 11. So that length right here is 11. Let's see, I want you to try B and C on your own. Pause this video, then we'll go over it in a moment. Okay, let's look at these two. Let's see. This time they kind of tilted the trapezoid on us, so our two bases are right here. And we know there are two bases because they're the two marked with that little arrows showing us that there are two bases, the little triangles. So one base is 10, the other base is 6. So that means the length of that midsegment is going to be 1/2 times the sum of both of the bases. So 10 plus 6. Well, let's see, 10 plus 6 is 16. 1/2 times 16, well, that's 8. So this length right here is 8. Last one, let's see, our two bases are 24 and 18. So our calculation is going to be 1/2 times 24 plus 18. Well, 24 plus 18, that is going to be 42. 1/2 times 42 that's equal to 21. So this right here is 21. Okay, another practice problem. The following shape is a trapezoid. Find the missing angles. So since I know it's a trapezoid, that means I need to have two parallel bases. If I look at this picture, these are going to be my two parallel bases. I can tell that because clearly this side that I'm highlighting in red and this side I'm highlighting, the other side in red, clearly not parallel. They'll clearly meet. Since it's a trapezoid, I know that there needs to be two parallel bases. The two that I marked as parallel can be the only possible pair of bases that could be parallel. So let's see. I have two right angles. I have a 146-degree angle, and I have angle W that I don't know. Well, I know my angle sum of a quadrilateral is 360 degrees, so I can set up a little equation. 90, remember all right angles are 90 degrees, so 90 plus 90, those are my two right angles, plus 146, plus W has to be 360 degrees. Now let's see, 90 plus 146. I added that up, that is equal to 326 degrees, plus W has to be 360. Well, if I subtract 326 degrees on both sides, that is then we are left with W is equal to 34 degrees. So W right here, 34 degrees. Okay, find the length of the missing base. So let's see right here, and they don't tell us this, but, or I guess they do kind of tell us. This VW, that is actually the mid-segment right here. Mid-segment. And why we know that is because it is parallel to both our bases FE and CD. That's our mid-segment. Well, let's see. We know that our mid-segment, how we would calculate that is we do 1/2 times the sum of both of our bases. So FE is 18. Well, let's see. We don't know what CD is right now. I'm just going to label that as X. So we're going to pretend that the length of CD is X. So 18 plus X, well, that's supposed to be 28. Now I'm just going to take a moment. I'm going to solve this equation just like normal. We practice this a lot in algebra. So the first thing I'm going to do is I'm going to distribute. So then I'm left with 1/2 times 18 plus 1/2 X equals 28. Well, 1/2 times 18, let's see, I'm just going to skip down a second, is 9 plus 1/2 X equals 28. Well, if I subtract 9 on both sides, working to get X by itself, I'm left with 1/2 X on that left side equals 19. Let's see, now what I can do is I can times the whole thing by 2 to get rid of that 1/2. So I'm left with X equals 38. So this length right here, I'm highlighting in blue, is 38. And if you wanted to double check, you could do the 18 and 38 back into that original mid-segment formula. See that 1/2 times 18 plus 38 is in fact 28. Okay, let's look at another practice problem. So again, they gave us our mid-segment of 15, but we need to find is that one base X. And again, we know that these are our two bases right here, and they didn't label it, but we can mark it here. They told us it's a trapezoid. We know that clearly our other two sides aren't parallel. That side that's labeled with the 22 and X have to be our parallel bases. So we can set up a formula just like before. If I wanted to find the mid-segment, I would do 1/2 times 22 plus, well, I don't know the other base, but I know it's going to have a length of X. We're going to solve for that. And that has to be 15. Again, I'm going to distribute. So I get 1/2 times 22 plus 1/2 X equals 15. Well, 1/2 times 22 is 11 plus 1/2 X equals 15. If I subtract 11 on both sides, working to get x by itself, left with 1/2 x equals 4. To get rid of that 1/2, I'm going to times the whole thing by 2. So I'm left with x equals 8. So this length right here is 8. Let's see, this is our last problem. I want you to try it on your own. Pause the video and we'll go over it in a minute. Okay, let's go over this. We see that we have a mid-segment labeled 9. We have two bases, one that has a length of x, and another that has a length of 13. Again, we're going to use that mid-segment formula to solve. So we know that 1/2 times x plus 13 has to equal 9, the length of our mid-segment. First distribute, we get 1/2 x plus, well, 1/2 times 13, that's 6.5. That should be 9. I'm going to solve for x, so I'm going to subtract 6.5 first. I'm left with the 1/2 x on my left side and 2.5 on my right side. To get rid of that 1/2 that's being multiplied by the x, I'm going to multiply by 2. So I'm left with x equals 5 as my final answer. So this length right here, highlighted in green, is 5. Thank you for watching this video on trapezoids, and you can work on your homework now.